Hi, good morning. Welcome back to EV channel. So today we are going to explain you what is the importance of an MECO made phase sequence indicator or phase sequence detector, and we'll try to do what is the need of this phase sequence detector, and we'll try to demonstrate it by connecting to a three-phase squirrel cage induction motor. Just coming to the basic need. So we are having an three-phase supply. This is R, Y, B. Actually, as per the given sequence, we are directly connecting to the input of an three-phase variac. So we have been connected to the input of an variac. This is R, this is Y, and this is B. We connected to the input of the supply. The output of the variac we are going to connect to the R terminal, which is nothing but how to give this connections is in the stator we have three types of winding. We are bringing those terminals as A1, A2 is one set of coil, B1, B2 as another set of coil, C1, C2 as another set of coil. So here you can see this A1, A2 is one set of winding, B1, B2 is another set of winding, C1, C2 is another set of winding. Now I want to connect them in delta fashion. So very simple. So join B2 terminal to A2, join B21 C1, join C21 A1. So then you are going to get one resultant. So from this resultant we are going to give, or from these two ends we are going to give Y, and from this resultant we are going to give B supply. So this is nothing but the stator of an squirrel cage induction motor. We are exciting the stator. By the principle of induction, the rotor will try to rotate, and now we are connecting this phase sequence in this fashion. You can see here. So we are having RYB3 terminals. We are connecting R to the first one. You can see here, as per the connections given, A2 B1 is short circuited. Here you can see here A2 B1 is short circuited. Next one B2 C1 is short circuited. B2 C1 is short circuited. Next one C2 A1 is short circuited. C2 as well as A1 is short circuited by this wire. So now at the ends of A1, B1, C1 we are connecting three phases. You can see here at A1 end I am connecting R phase, at B1 end I am connecting so this is the B1 end, I am connecting Y phase. So you can see here this is nothing but I am connecting Y phase. Next one, when you come to this third phase, we are connecting to the B2 phase. Okay, so this is nothing but here we have been connected. You can see internally it is nothing but short circuited. Okay, so this we are connecting at A2, sorry, A1, B1 and C1. So at A1, B1, C1 we are giving the supply, and we are already connected them in delta connection. Okay, now let us try to see how the phase sequence operated. So actually observed the phase sequence and I had connected, and I will try to rotate this phase sequence in the original direction. The original phase sequence or the original three phase direction is, so this will try to rotate in clockwise direction, and this is the original phase sequence of the supply. And see the instructions how to operate this MECO made phase sequences. This is maximum will be operated for 30 seconds only. So more than 30 seconds you should not operate. So that's why we'll give the supply only for 30 seconds and we'll turn off, and we'll see the phase sequence. So now in order to understand better, I have been connected the phase sequence at the output terminals of the motor, and you can see the original direction of this three phase induction motor is clockwise direction. So now let us try to check out how the phase sequence going to apply. So I think connections is very clear. I am giving RYB input to the three phase variac, and the remaining RYB I am connecting to the delta connection of an stator of an induction motor, which is nothing but three phase squirrel cage induction motor. You may ask, sir, why you are not selected single phase? In single phase there is no need of phase sequence. That's why I selected three phase to show you the phase sequence. Now let us try to understand how the phase sequence meter is going to operate. So see here, I am going to turn on the supply, and you can see here the voltage between R phase and Y phase is approximately 420 volts, and this is nothing but the auto transformer. Slowly we are adjusting the input voltage such a way that we can apply an regular voltage. So you can see the direction, that is the original direction of the motor. This is the original phase sequence of the supply. Okay, if the original phase sequence is correct, automatically motor will try to rotate in the clockwise direction. If the phase sequence is reversed, you can see the motor can rotate in opposite direction. So this phase sequence is very important when you are joining two ends of a cable. If you want to use in industry, you have to join the ends of a cable as per the phase sequence. Then this instrument plays a major role. So let us try to demonstrate it. See here, I am applying some lower voltage, and you can see here the phase sequence will try to rotate. So you can see the rotor has started rotating, and the phase sequence is also started rotating. So the phase sequence is rotating in clockwise direction, and rotor is also rotating in clockwise direction. What is the conclusion is phase sequence is original as per the clockwise direction. That's why motor is also rotating in clockwise direction. So that is how to identify the checking the how to check the original phase sequence. But actually they had given the connections as RYB, but that's not the original phase sequence. Original phase sequence is, so this is nothing but R, this is nothing but Y, this is nothing but the B where we are connected. So the first end is acting like an R phase, second end is acting like an Y phase, this end is acting like an B phase. This is the original phase sequence. That's why the motor is rotating in clockwise direction. Let's try to see how to operate in reverse. You can see here now the phase sequence meter was rotating in forward direction, I mean clockwise direction, and your motor is also rotating in clockwise direction. Let's try to demonstrate how it to be operated in reverse direction. So in order to reduce the speed, so in the upcoming video, we will show you how a rotating magnetic field is produced in an three-phase induction motor. So this is the original phase sequence. If it is given in industry, it will rotate as per the design direction of the motor. If you want to change, for example, in conveyor belt, you want to reverse the direction of the rotor, then you can change the phase sequence. Then the motor will rotate as per the required counterclockwise direction. So how to change the direction of the motor? So you can see by the help of an phase sequence also. First you have to turn off the supply, and you have to plug it out the terminals. So you see here previously this was connected to R and it was connected to Y. Just I am shuffling, just I am changing only two phases. So this is the phase, I am two whites I am changing, and then just I have been changed the phases, two phases have been changed. So now as per this phase sequence analysis, so the phase sequence indicator was rotating in clockwise, now it has rotated in counterclockwise, and you can see that phase sequence has been reversed. Automatically your rotating magnetic field developed by the stator also will make the rotor to rotate in counterclockwise direction. That is what the theme of this experiment. Main intention of this experiment is to show what is the importance of phase sequence detector or indicator. Let's try to demonstrate that concept. So now again you should be very careful. Why? Because this is an 415 three-phase supply. Just give the three-phase supply, and you can see here the phase sequence is rotating in counterclockwise direction, and you can see here the rotor is also rotating in counterclockwise direction. That's what the theme of the experiment. Slowly it will try to, you can see here, slowly it will try to come to, originally it was rotating in clockwise direction. Now you can see here in the video it may not be very clear. So when you see clearly, so now it may be visible to you. So now it is trying to rotate in counterclockwise direction. So you can see here why I have been removed the supply is you should not give the supply more than 30 seconds. What will happen if I give more than 30 seconds? The instrument will damage. So that's why you should be very cautious while operating this device. Let's try to check the phase sequence for your analysis. So we are trying to excite it. Just be careful with this three-phase supply. You should keep the rheostat in zero position and not apply the voltage. You can see here this is still in standstill position, and rotor also in standstill position. Original direction is clockwise direction. Now let's try to make it rotate in anti-clockwise direction or counterclockwise direction. So slowly I am applying the voltage. So slowly if you apply the voltage, you can see here your phase sequence meter is rotating in opposite direction. Okay, so it started rotating in counterclockwise direction, and automatically the rotor is also rotating in counter. You can see this meter. If it is rotating in reverse, automatically the motor also will rotate in reverse. So that is the importance of three phase. How to change the phase sequence and how to make the rotor to rotate in opposite direction is very important. So that's what the theme of this experiment. So thank you for watching patiently. Please like and subscribe for more videos in our channel. Thank you.